series. So while I've got the TIG torch set up, I'm going to use it to tack weld with. Now what I like to do for tack welding sometimes is put the tip way up in there like that, crank the amperage up to maybe 1.5 to 2 times what I would weld at, in this case 175 amps, prop the TIG cup, press the trigger, and zap. It's just that quick, and it's pretty much foolproof because the tip of the electrode can't really get crapped up because it's kind of almost below flush, and it just puts a really quick, almost like a laser zap on the end there. So once I get all these tacked up, I will switch over to the MIG machine. It just made sense for some reason for me to do it this way. Now to start off, I'm going to be 19 volts, 330 inches a minute with 0.30 diameter wire. That's 0.8 millimeter diameter wire. And I'm going to start off with a little bit of a push angle, using just a little bit of gun manipulation. This is kind of like, I don't know, I'm just in the habit of doing this, especially on when I'm using the 0.30 wire and short circuit MIG. I'm just in the habit of doing a little bit of oscillation like this, a little series of loops. And I may have to get out of that habit, to be honest with you, but old habits are kind of hard to break. They say that it's supposed to set the machine where it sounds like bacon frying. Probably a pretty good idea. All right, that's the finished joint there. You can see a little bit of spatter there. That's typical when you push, unless you turn the wire feed speed up quite a bit higher. There's always lots of discussion on pushing versus pulling, and I think that really comes from because there are so many different modes of transfer. You know, there's spray transfer, short circuit transfer, etc. With short circuit transfer, I prefer to pull, but I push also. Just depends on the situation. I've done these kind of tests before. I generally get a little bit better penetration pulling, a little less spatter pulling, but not much difference. Not like night and day. There are subtle differences in the bead profile and penetration. But we're going to test it and show what each one does. All right, that's a series of sort of like U's or cursive E's, and which one you use will determine how much buildup you have in your weld, and it also affects your travel speed. Like if I'm looping back into the weld like this, that's going to build up a little bit more, and that's going to slow down travel speed. Whereas if I don't loop back into the weld at all, I just keep moving forward, that speeds up travel speed and usually, you know, spreads the ripples out and doesn't build up as much. All right, just for kicks, because the machine I was working on also stick welded, I decided to throw a 3/32 7018 in. A funny thing, that probably sounds more like bacon than any of the MIG welds, right? But I just wanted to, since I'm going to slice and dice these things and check for penetration, I kind of wanted to see how the stick weld fared, how it compared to short circuit MIG. Now, I ground some teeth in this cheap half-round file, and that's kind of a handy tool to have when you're stick welding for scraping slag off. Works especially well on pipe. So now it's time to cut all these, kind of see where I'm at. Get a little polish on them, put a little acid etch. Let me remind you here what the puddle looked like on the pole. And then we'll put a little acid on there and see what we got. One on the right, slightly better than the one on the left. But both of those were pulling. Now here comes the push. We'll give it a quick acid etch, and you can see the penetration on that bottom plate is a little bit less than it was with the pull. There they are side to side. Again, not like night and day. The differences are subtle. It could have been me. I could have had my gun angle a little off. I don't know. But that's a consistent result I get when I do push versus pull tests. All right, since I threw that 7018 332 rod in there and did a little single pass weld on that, let's take a look at what that cross section looks like. One on the left definitely got a little undercut, but I am surprised at how little it penetrated the bottom plate. All right, quickly, a little outside corner joint. you don't really have much room to do much manipulation of the gun here, so oftentimes, something like this, you might just do a straight drag, a straight push, or a little stitch back and forth type motion, forward and back, or forward and pause, I should say. I am not really very good at this. I need some practice on this particular joint here. I think there's a way to set the machine with high inductance and kind of low wire feed speed to let the bead kind of fan out, but I'm still working on that. Let me show you some clips for some previous videos here. This is some 035 wire overhead, higher settings, 20 volts, 300 inches a minute with 035 wire. You need to set the machine good and hot for overhead, which might be counterintuitive to what some people think. You set it nearly as hot as you would just welding flat or horizontal. All right, here's a joint, a vertical uphill with the 035 wire. Here's a technique I like to use, a little series of overlapping triangles, sort of.